Okay, so today I'm going to show you guys how we find the roots of a quadratic function. So last time we saw how to factorize a quadratic function, in particular a quadratic trinomial. Today we are going to solve quadratic functions. So I have them in different forms right here, and I'm going to take them one at a time. We'll see how we go about solving them. So here, for question number 1, I already have a quadratic that has been factorized. So factors, apparently, that are given are x minus 4 times x plus 1. So a lot of my work has already been done for this first one. What we're going to be doing is factorizing, but for this particular question, it has already been factorized. In order to solve it, we let it equal to 0. This is going to allow us to, what we call, find the roots of the function. And here's what we do. We say this quantity x minus 4 times this quantity x plus 1 is equal to 0. In that case, it follows that either this quantity is 0 or this quantity is 0, because their product is equal to 0. And so we say that x minus 4 is equal to 0, or x plus 1 is equal to 0. And we solve both of these equations now. If x minus 4 is equal to 0, well then x is equal to 4. That is one of the solutions to my original equation up here. If x plus 1 is equal to 0, well then x is equal to negative 1. And that is another solution to my original equation up here. And those are my answers. These are the solutions to this equation. They are the roots of the function, call them what you will. These are my two answers. X equals 4 and x equals minus 1. So that one was pretty easy because the function was already factorized for us. Let's take a function where we have to actually do the factorizing ourselves. So what I'm going to do, I'm going to erase, go on to question number 2. So in question number 2, I have to actually do the factorizing. So I'm given a function, quadratic trinomial, 6x squared minus x minus 2, and it's equal to 0. Before we didn't have this equal to 0, now we do. We let it equal to 0 in order to find the roots, in order to solve it. Okay, well, we've had some practice with solving quadratic trinomials now, so let's put that practice to good use. I have two factors. I have here 6x squared. So my two factors may begin with 2x and 3x. Could also have been 6x and x. I'm not sure. I have to do a little trial and error. But I'm going to try 3x and 2x. I have a negative sign here, which means that the signs here will be plus minus or minus plus. I have a 2, so I need the factors of 2. Those are going to be 2 and 1. So what I think I will try is minus 2 plus 1. Minus 2 times plus 1 is minus 2, so I have got factors of minus 2, so that's good. Let's just check if I have actually, if they sum to this middle term. Minus 2 times 2x is minus 4x, and 1 times 3x is plus 3x. Minus 4x plus 3x is negative x, which is that middle term. So sure enough, these are, in fact, the factors. So the factors are 3x minus 2 times 2x plus 1. Okay, I'm just going to erase this right here. I know I have the factors now, and so it remains only to solve it in the same way that we solved the first question. Having factorized it, I can say that this quantity, 3x minus 2, times this quantity, 2x plus 1, is equal to 0. That's what my equation tells me. Well, it follows that either 3x minus 2 is equal to 0, this quantity is equal to 0, or 2x plus 1 is equal to 0. If 3x minus 2 is equal to 0, solving this then, I get that 3x is equal to 2, adding 2 to both sides, therefore x must be equal to 2 over 3. That is one of my solutions. That is one of my roots. Solving this one, 2x plus 1 is equal to 0, well therefore 2x must be equal to negative 1, and therefore x must be equal to negative 1/2. And that is my other solution, that is my other root. And so I have found the two roots. By first taking my quadratic trinomial, factorizing it, and then solving the equation. All right, so that's those first two done. Let's try something, an equation that's a little bit more challenging. So for number 3, I have x minus 3 times x minus 2 is equal to 20. Okay, so notice I don't have a 0 on the right-hand side this time. So what I'm going to do is I'm going to FOIL this out first. That's what I'm going to start with. I'm going to FOIL here first, outer, inner, last. So x times x will give me x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is plus 6. And we know that this is equal to 20. Gathering up my like terms and bringing my 20, subtracting 20 to the left-hand side, I get x squared minus 2x minus 3x is minus 5x, plus 6 minus 20 is equal to 0. I subtract 20 to the left-hand side. I'll gather up these two terms. These are like terms. X squared minus 5x. 6 minus 20 is negative 14. That's equal to 0. And now I have a quadratic trinomial equal to 0. I'm now going to factorize this quadratic trinomial, if I'm able to do that. I know that it will be equal to 0, and x squared there will give me an x and an x. I have a negative 14, so I need factors of negative 14. That will sum to negative 5. So maybe minus 7 and plus 2. Minus 7 and plus 2 are factors of negative 14, so let me try that. Minus 7 plus 2, and if I just check it, here I get minus 7x. And here I get plus 2x. Minus 7x plus 2x is minus 5x. That's that simple term. So I have got the correct factors. X minus 7 and x plus 2 are the correct factors. And so now I do what I have done before. This quantity x minus 7 times this quantity x plus 2 is equal to 0. It follows that x minus 7 is equal to 0, or x plus 2 is equal to 0. If x minus 7 is equal to 0, then x is equal to 7. That is one of my solutions. It's one of my solutions to my original function up here, my original equation. If x plus 2 is equal to 0, well then x is equal to negative 2. And that is my other solution. Those are my solutions, my roots, 7 and negative 2. And that's our problem solved. Notice, like I say, in this one, we had to gather up our like terms. We had to FOIL it out, gather up our like terms until we were in the form of a quadratic trinomial equal to 0. And then we factored it again and let those factors equal to 0 and solved it.